Hi everyone. So come to the question number 6 in the section B. The continuous random variable x has the cumulative distribution function, which is given as a fx. Then we can see that there is a 4 interval. There are 4 intervals for x less than 0, that's 0. 0 to 2 is x squared over 6. 2 to 3, this is the function. And x greater than 3 is 1. We need to find the median. Given that the median is giving this fact, f of m equals to 0.5, meaning that we sum up all the probability from negative infinity up to the m. This probability over here, the area under the curve, is equals to 0.5. Okay, so now we are going to use this formula to find our m, but we do not know whether the m is either located in the interval of 0, 2 or 2 to 3. So we need to test. How to test? We can substitute the 2 into this function, that is a 2 square over 6. From here we get a 4 over 6 or 2 over 3. Then we can be sure that 2 over 3 is greater than 0.5. So meaning that the probability up to the 2 is already exceed 0.5, meaning that our value of m, the median, okay, the median, if let's say this is a 2, okay, the median will be fall in between 0 and 2. All right, 0 and 2. So we can be sure that now we can substitute the m into the first formula is over here, which is your m squared over 6 equals to 0.5. From here, we solve for the m. So since the m should be located in between 0 and 2, so we say that the m will be equals to third of 3. That is 1.7321. Next, we need to find the probability of 1 to 2.5. Okay, so for the probability of 1 to 2.5, we can use f of 2.5 minus f of 1. So substitute 2.5 into the second formula over here, or we say that negative x squared over 3 plus 2x minus 2. Substitute 2.5 into that, and then substitute the 1 into the second formula over here, that is x squared over 6. Then we minus the probability, we can get the answer. Alright, substitute into the formula, into the cumulative distribution function, follow the interval, then you will get this 3 over 4, or in the decimal 0.75. Okay, so for the part C, we need to determine the probability density function, meaning that from this cumulative distribution function, we need to convert back to the PDF. We need to differentiate. So just differentiate these two functions. Then later on, you add one more line for the 0 otherwise. So what I mean over here is, for the interval 0 to 2, we need to differentiate the x squared over 6. So the function is 2x over 6. We get x over 3. Alright, this is the function, the first function for the PDF. Alright, for the next interval, 2 to 3, we need to differentiate this this function. So we'll get negative 2 over 3 x plus 2. Alright, then for otherwise, for other interval than 0, 2 and 2, 3, that will be 0, fx equals to 0. So when we write in the complete form of the PDF, that is a probability density function, we should have 3 lines. The last line, it should be 0 otherwise, meaning that other than these two interval, all the interval having the fx equals to 0. Okay, so this is our fx, the complete form, the probability density function. For the interval 0 to 2, if we need to sketch the graph, we need to focus on this interval. We have only two non-zero function, that is from 0 to 2, and the other one is 2 to 3. So from 0 to 2, the function is y equals to x over 3. This is a linear function where we have a line which is going up, because the gradient is a positive 1 over 3. So we can draw a straight line, passes through the origin, alright, just like this. And then you have to know what is the value of this. Yeah? When the x equals to 2, y equals to 2 over 3. You just can substitute the 2 into this, first function, that is a 2 over 3. For the second function, from 2 to 3, we got a linear graph also, but the graph is going down because of the gradient is a negative, and then you have a plus 2, meaning that if let's say negative 2 over 3x only, you might have the graph like this, passes through the origin. And then plus 2, meaning that your graph is going up for 2 units. It's like this. But now we're just interested from the graph, this graph, from 2 to 3. So we have to figure out what is this point, and then we plug in this corresponding portion into our graph. Alright, so this is the point of a 3. You can say that, okay, you can check. What is the value of the y for this function when x equals to 2? Just put in the value over here, and then you calculate what is the y value it will give you. So when x equals to 2, plug in the 2 into this function, you also get a 2 over 3, meaning that when x equals to 2, it is equals to 2 over 3. Alright, then when x equals to 3, okay, you can have substitute the x equals to 3 inside here, you will get 0. So just use your ruler to connect them, these 2 points together. Okay, so you will get a triangle. Okay, so this is the graph.